I'm currently the tech lead for the mobile platform team at Uber. So today I will talk about how we have rebuilt our Android Rider app. So about last year, we decided to rewrite our Android Rider app, and there are a lot of reasons why we want to do that. For example, like for business, we want to build a new app so that we have a better platform to support our growing user base, like for our app. From a product point of view, we want to provide a fresher and newer user experience. And then for the technical, we want to build new app and new framework so that we can scale as we grow the size of our team. At the same time, though, like rewriting our app create a very rare opportunity for us, so that we can really rethink about our approach to mobile performance from the ground up. Up until that point, like of course we have done a lot of optimization in the old mobile rider app. We have tried different techniques to optimize like the performance here. Most of the time, though, we use like off-the-shelf tools, right? So you guys all have seen like trace view or six trace and stuff like that. But one thing we realize with Uber is that because our business is scaling and we have to support like hundreds of different cities around the world, and we have thousands of ongoing experiments. So the number of combinations of user experience just keep exploding really quickly. So it's very difficult for any single developer to really understand what the user experience of a particular user is like. As you can imagine, like the user experience for a user in San Francisco with the latest and greatest device is completely different from a user in India with a budget and Android Go, like we saw in the previous presentation. So what we decided with that, we want to have a new approach to performance, right? And we want to change our thinking toward performance. And then once we have the new approach, then we use this same approach and apply it to different focus part of the app. So it can be from design to architecture to networking to tooling. So I'm gonna walk you guys through some of those examples, and guys can see how we use that approach to change the performance and the user experience of our app. And hopefully, like from some of those learnings, you can bring some of that into the own application. Okay, so we have to start from somewhere. And the very first thing we know that we cannot build a perfect application right away. There's no way we can do that. And even if we can build like an application that is so fast from the beginning, from day one, it's gonna getting slower and slower. So what we really need is a framework where we can constantly improve on the performance of the app, right? So once we decided that, we created a very simple framework. The very first step is measurement. So this is not very difficult to imagine. I mean, anyone who have been dealing with performance is going to tell you that you have to measure before you can start really working on performance. One key difference here is that because of our previous experience, we know that we have to rely on the production from our real user in the wild. We cannot just try to look at our data in the lab and then use that. So production is a source of truth for this. Once we have measurement, then of course the second step is start doing some optimized steps. So people have talked a lot about like how we do optimization, what are the type of optimization that we can do. The fact of the matter is, optimize is actually fairly easy. Like it's very much dependent how well we do in the previous step, right? If you have a very high level, very like coarse-grained measurement, then you can only do certain kind of optimization. But if you have a really good, really fine-grained measurement, then you easily detect what are the hotspots in the app. And so once you see that, then like the optimization is really straightforward. Most people working on performance, they stop here. They have these two steps. It's not really new. But what we introduce is a third step in the process. So we want to have the ability to enforce. What does it mean? It means that like when you make some improvement, we want to lock in those games. We don't want to like you have regression and you immediately lose the game, right? So by having the ability to enforce, basically you keep lowering the performance bar, like and if you connect the whole loop, then you have a framework, right? So you start out with doing some high-level measurement. With the high-level measurement, you can do certain type of optimization, and you use an enforcement framework to log in the gain. And then after you do that, you can come back to do like more measurement. This time, hopefully, you can do more fine-grained measurement, and you open a new set of optimization and so on and so forth. Once you do that, then you have a framework that you can constantly driving the performance of the application. So let's talk a little bit about like startup performance. Of course, from the title, the top, you guys can guess that we spend quite a bit of time on the startup performance of the app. Like you might ask, why do we spend that much effort into it? There are a couple different reasons to it. One is that this is a very well-known problem in the industry. Right? So, company like Google, Amazon, they have spent a lot of time doing study, and what they found out is that like when you improve the performance of the app, like the other user metric improve quite a bit better as well. From our previous experience of working on the Uber app, we see the same thing. Whenever we improve the performance of the app, we see that like our user engagement increase. So users open the app more often, like taking more trips and stuff like that. Right? The second reason is slightly more specific to the Uber app, because the session for the typical session for Uber is quite short. Like users open the app and they really want to book a trip or whatever they want to do, and then they want to close the app as soon as possible. So a typical session is about like 30 to 40 seconds. So if the app takes a really long time, takes several seconds to open, like just become a really annoying experience very quickly. Also, like the user tend to open the app multiple times during the trip, right? They want to check on the status of the driver. They want to see the ETA of the trip, so they open the app, and they want to quickly get that information. So, like again, if the app is slow to respond, that makes the user have a very bad experience. And the last reason is a more technical reason. It's because like startup use case is one of the most difficult use case when it comes to performance. It has a very mix of different workflow. Some workflow is very I/O bound, some other workflow is very CPU bound. So if you can build some tooling that solve the startup performance well, you basically guarantee that it's going to work for other use case in the application. Okay, so let's see how we can define like startup performance, right? At a high level, it's quite easy. It's basically the time from when you open the app to when the app is started. So you would say, okay, when you open the app, it's basically application on create, very first line like of the code that execute, right? But then application started is slightly trickier. There are multiple different definitions for that. Is that like when the user, when the UI is visible to the user, like when the user is ready for interaction? Is like there are different reasons. There are different ways of defining that. So for us, we define that as when the UI is ready for interaction. It means that like the UI is totally visible to the user, and the main thread is free. So like if the user tap on like a button or something like that, like there's going to be some action right away. Now, however, this thing is actually not very true. This is actually not the very first thing that the user see, even though that's the very first line of code that you wrote. But the user interacts with the app way earlier before that, right? From the very first moment when they tap on the icon in the home screen, Android already going to do something like it's going to start a new process. It's going to load the code into memory, and it's going to do one thing. Even though you have very little control during this period, it actually can affect your performance quite a bit if you're not careful, right? So one example of how this can affect is that if the application is become like from a single deck to multi-decks, now Android have to load way more code and it's going to be a lot slower. Is one example. And of course, like I mentioned before, we really want to break down like our measurement, right? We don't want to have a single measurement, very high level. We want to have smaller, more fine-grained measurement. Here's a couple of examples how we can do that. So this point here is when user started to see something, right? The very first animation is going to run, user going to see something moving on the screen. This point here, for example, is like when the UI is settled, the user are going to see the final UI. They might not be able to interact with that UI yet, but they have some time to process what's on the screen for them. So this is this is not exactly how we do it, but this is some high level suggestion how you might be able to do it. Okay, so startup performance, startup animation, sorry. We spent quite a bit of time debating on whether we should have an animation when you open the app or not. So this is a debate that many teams, many apps have as well. If they want to have a really fast user experience, many apps just like disable the startup animation, right? But at the same time, if you want to provide somewhat a delightful user experience, there's many companies who they show very fancy user animation at the beginning. The problem is that if you show a very delightful, very fancy animation, it's going to slow down the performance of the app. So how do we balance that? So at the we was lucky that we found like a sweet spot, which is basically if you can run your animation in parallel with the code, then you can get the best of both worlds. And we achieve that by running the startup animation on the render thread, right? So if you look at this this thing right here, you can see that like a zooming animation happening at the same time that like other UI element get rendered underneath it. So we didn't really spend much time on the animation itself, but we using the animation to cover part of the loading of the UI. Now, the problem comes when render. Okay, so we mentioned that we want to support like non-blocking network call in the app. And in order to do that, then we have to provide a meaningful user experience for the user, even when the network is slow. So this is one example of when we're doing that. This is our search capability. And what we have here is that we download and index all the historical result and all the POI around you, so that you can search completely offline or when the network is slow. In here you can see that like even though we have the airplane mode on, when you type in Starbucks, we can show you like all the Starbucks around you. This works like a mini version of our search engine in the backend. It has all the same kind of feature like doing query matching by like distance, doing like personalization, have some like have some ranking using the distance and stuff like that as well, right? And then we implemented it using SQLite full text search. After we raw this feature, what we found staggering was that 75% of users move through the whole flow even without making a single network call. So even though we built this feature initially for like user on slow networks, it turned out that every single user actually love it and they use it more, right? So even when the network is, we have network, we have like 4G and whatever, users still prefer this experience because it's faster. We have initially, before we release the feature, we have people have like different discussion within the team about if we release this, maybe like the quality of the search result going to be lower, then people have to type more to get to the same result. But it turned out that the feature is so fast that even if users have to type more, they end up go through the whole flow much faster than before. So what started out as a feature that only work for user in slow network, we roll it out and we make it a main feature, and now it's enabled for default so that every user have it. And then we found that by doing that, then our click-through rate and then our speed of getting through this flow increased very, very well. Okay, so we mentioned that we want to support like non-blocking network call in the app. And in order to do that, then we have to provide a meaningful user experience for the user, even when the network is slow. So this is one example of when we're doing that. This is our search capability. And what we have here is that we download and index all the historical result and all the POI around you, so that you can search completely offline or when the network is slow. In here you can see that like even though we have the airplane mode on, when you type in Starbucks, we can show you like all the Starbucks around you. This works like a mini version of our search engine in the backend. It has all the same kind of feature like doing query matching by like distance, doing like personalization, have some like have some ranking using the distance and stuff like that as well, right? And then we implemented it using SQLite full text search. After we raw this feature, what we found staggering was that 75% of users move through the whole flow even without making a single network call. So even though we built this feature initially for like user on slow networks, it turned out that every single user actually love it, and they use it more, right? So even when the network is, we have network, we have like 4G and whatever, users still prefer this experience because it's faster. We have initially, before we release the feature, we have people have okay. So we mentioned that we want to support like non-blocking network call in the app. And in order to do that, then we have to provide a meaningful user experience for the user, even when the network is slow. So this is one example when we're doing that. This is our search. Search capability. And what we have here is that we download and index all the historical result and all the POI around you, so that you can search completely offline or when the network is slow. In here you can see that like even though we have the airplane mode on, when you type in Starbucks, we can show you like all the Starbucks around you. This works like a mini version of our search engine in the backend. It has all the same kind of feature like doing query matching by like distance, doing like personalization, have some like have some ranking using the distance and stuff like that as well, right? And then we implemented it using SQLite full text search. After we raw this feature, what we found staggering was that 75% of users move through the whole flow even without making a single network call. So even though we built this feature initially for like user on slow networks, it turned out that every single user actually love it, and they use it more, right? So even when the network is, we have network, we have like 4G and whatever, users still prefer this experience because it's faster. We have initially, before we release the feature, we have people have like different discussion within the team about if we release this, maybe like the quality of the search result going to be lower, then people have to type more to get to the same result. But it turned out that the feature is so fast that even if users have to type more, they end up go through the whole flow much faster than before. So what started out as a feature that only work for user in slow network, we roll it out and we make it a main feature, and now it's enabled for default so that every user have it. And then we found that by doing that, then our click-through rate and then our speed of getting through this flow increased very, very well. Okay, so we mentioned that we want to support like non-blocking network call in the app. And in order to do that, then we have to provide a meaningful user experience for the user, even when the network is slow. So this is one example of when we're doing that. This is our search capability. And what we have here is that we download and index all the historical result and all the POI around you, so that you can search completely offline or when the network is slow. In here you can see that like even though we have the airplane mode on, when you type in Starbucks, we can show you like all the Starbucks around you. This works like a mini version of our search engine in the backend. It has all the same kind of feature like doing query matching by like distance, doing like personalization, have some like have some ranking using the distance and stuff like that as well, right? And then we implemented it using SQLite full text search. After we roll this feature, what we found staggering was that 75% of users move through the whole flow even without making a single network call. So even though we built this feature initially for like user on slow networks, it turned out that every single user actually love it, and they use it more, right? So even when the network is, we have network, you have like 4G and whatever, users still prefer this experience because it's faster. We have initially, before we release the feature, we have people have like different discussion within the team about if we release this, maybe like the quality of the search result going to be lower, then people have to type more to get to the same result. But it turned out that the feature is so fast that even if users have to type more, they end up go through the whole flow much faster than before. So what started out as a feature that only work for user in slow network, we roll it out and we make it a main feature, and now it's enabled for default so that every user have it. And then we found that by doing that, then our click-through rate and then our speed of getting through this flow increased very, very well. Okay, so we have talked a lot about device performance. So now let's switch mode a little bit and talk about networking performance. That's another important area. So for the new app, we build a completely new custom protocol for push. This push channel is supposed to be used when the user is opening the app and the user is looking at the app. So we build a very high channel protocol based on server send events. And then people started to using it everywhere in the app, right? So starting from an old app where we mostly doing polling to the new application where like I think the majority of our traffic is going through the new push channel at that point. So initially people were using it for simple kind of use case. You can imagine like we have a two app, rider application and driver application. Some use case that we're using it for is like when the driver accept a trip or something like that, then we automatically want to push that to the rider app and notify the user that okay, users go on a trip. So we have that using this channel. Another feature is on the driver app, we automatically upload like GPS location. So in the rider app, you can see like all the GPS point in real time and see the car moving. So this using this feature as well. Those are the kind of like traditional features that we can enable on top of this. But we found that people were very creative. Like once we have a very stable, very high performance channel, they actually found a lot more creative use case to use on top of this. So I can talk more about some of those cases. So let's talk a little bit about like the model of the Uber app so that you guys can understand. So this is a very simplified model of the app. At the very top, we have a where to button, basically for you to enter into a destination, and then we can route you to that destination. In the middle, we have a bunch of like nearby cars that moving in real time. You can see up to like 8 cars, something like that. You can see the car is moving in the map, and then yeah, I think like just download the last 10 seconds of your GPS point, of the car GPS point, something like that. At the top, we have a bunch of suggestions. So this suggestion can be based on what we know about the current context. So it's based on current time, current location. It can be like the event that you're going to go to next. It can be based on the calendar. It can be based on the historical result. You're more likely to go this particular place at this time, maybe like work or home or something like that. It can be also like popular places of interest around you. So we have a bunch of those up top. And then at the bottom, we have a feed. So this is used as a single communication channel in our app, right? So the same as the suggestion, this is a very context aware. So it have know about time, location. It can change depend on that, and it aggregate data from multiple sources and to create this feed. Okay, so now we understand about that model. Then we can take a look at the particular use case. So this is a feature. This is an old model of a startup, and we call it non-progressive startup. So what happens is when you open the app, right? The app doesn't have anything. The very first thing that you're going to make a network call to the server, and the server is going to return some information. So in this case, it's going to return you all three information. Like this small chunk is enough for you to render like the cars. This like oranges block is for you to render the session, and this bigger block is for you to render the feed. Right? You can see it combine all the data in one and slowly moving them through. So this is how a normal application should work. But this is very inefficient because, like, you can understand the only thing the user needs is actually looking at the car, right? I mean, that's plenty of information for them to process initially. And then, in order to render this, you only need like a very small bit in the actual payload. So wouldn't it be nice if we can only send this call package first, and then like render the UI? So that's what we enable with progressive startup using push. So the UI end up looking like this, right? So see much faster. So how it works? Okay, let's play that again. Right? So the initial request now only return one thing. Now it's only return like the car location, and that's enough for you to render the car location. At the same time, this is using as a trigger to push additional data to the app, right? With various priority. This can be like lower priority. This can be lower priority than that. And then whenever we receive the data from push, then we're going to render them on screen. So with this, our user see an experience, see some data, the main data right away, and then whenever the additional data, the secondary data come in, we render that. So we have a lot of success with the push channel, push infrastructure in general, and we extended that to support background push. So what background push is? The current push channel that we have only work when the user opens the app, right? Because it's a very high power, it's using a lot of battery. We only want to use it when the user is actively looking at the app. But there are use cases when you want to push your information even when the user is not looking at the app. So we build those and leverage GCM and APNS for this use case. Basically, how it works is that we're able to push the data to the Uber app even when the user is not looking. We're not doing anything with the data. We just hold on to the data, and then later on, when the user actually opens the app, then we start like interact on this new information. So by doing this way, we are very efficient in terms of battery usage and stuff like that, right? We don't burn the user battery because we leverage GCM and APNS. But we integrated this into the same kind of push infrastructure. So when a backend developer thinking about building a new feature, they don't have to think about which channel should I go through. They only need to say, okay, whether I want to push this on background or foreground, and we automatically choose the channel for them. Depends on the current state of the user. There is one very fun use case that we built for this particular feature here, just called calendar integration. So in the Uber app, there is a feature called calendar integration, which, like, if you add the calendar, if you integrate the Uber app with the calendar, then we index all the events that you're going to go to next, and we know when you're going to most likely order an Uber for the next event. Because we know that, we automatically calculate all the information needed beforehand and push that in the background to the app. So that if when the user actually open the app, then they have all the information ready at that point, like all startup information and all that. So we cut down like on everything. There's no, it's basically become like a warm start at that point, right? The user just bring up the app and they have all the information ready on their hand. Okay, so next up is about enforcement. So I talked a little bit about enforcement at the top. Remember, this is the most important step in this whole framework, because this allows you to log in again. Otherwise, you will constantly playing the catch-up game with the regression. Like the moment that you add in some optimization, you basically like lose them as soon as tomorrow or whatever. Even if you like try to think about, if you do one optimization, maybe tomorrow somebody like add a regression and you don't even know about it, right? So you constantly have to play catch-up. However, though, like the typical way that people think about enforcement is that they want to enforce against a particular goal, and that just doesn't work. Like people just think, okay, I want my startup performance of the app to be like below 2 seconds, and then you set up 2 seconds as a bar, and then in our experience, that approach does not work at all, and the reason is because it's very difficult to create a clean baseline for that, right? We found out that when you open the app on 2 different devices, you basically see like different performance characteristics altogether. They actually like on one device might be super slow compared to the other, and that's not due to the app but due to that particular device. So if you have a device lab or something like that, then you cannot really say I want 2 seconds across the whole device lab. Another reason is maybe because like the device have some other apps running on it, right? When you test it, then maybe like other app is doing indexing or something like that, and that's might like cause more I/O and cause the app to be slower, and we have very little control over it. So we can try really hard to control it, but then there's still another issue, which is like the OS itself, right? One simple example of OS is the very first time the app is running, Android doesn't know anything about the performance of the app yet, so they don't optimize, hasn't run a JIT on it yet. But when you run enough, then the hot code path is going to be JIT compiled, and then after that it's going to be very fast. And if you just like blindly kind of run it in the lab, you would never understand why suddenly like in some run you see the app is slow, and some another run the app seems very fast. So if enforcing performance go against the threshold doesn't work, then what works? What we found out is that you have to do similar to how you deal with user metric. You have to run proper A/B tests for performance. There are 2 parts to it. The first part is running on every div. Every time you check in code in master, we have to run the perf test some n times. It can be 10, 20 times before and after the code change. And if you do that, then you basically have 2 distribution of performance. And using like statistical analysis tool, we'll be able to say if this 2 distribution is similar or have a regression has been introduced here, right? So think of like how you normally run an A/B test or a particular feature. We run A/B test for performance here. The limitation of this approach is that it's very much depend on how many times you can run it. That's going to determine the sort of how fine grained you can do this, right? So because of that, we have to do it on every bill as well. So every time you cut the bill, it can be like weekly, it can be daily, whatever. We run a bunch more tests. These tests tend to be deeper and slower because you can increase the number of time you run it. Also, you can run a different type of test that is like normally take a longer time to run. And once you find an issue, then now you have to like backtrack, like you have to use my research or something like that. Like you have to backtrack to find the correct revision that caused the regression, and then you can like create a ticket or like assign to the correct owner. So that's about close to the end of my talk, and then I want to talk a little bit about like how you can, what you should take away from this talk, right? I mean, if all throughout the talk, like, if you don't remember anything, then just remember a few this point. The first is that the framework, right? The framework of measure, optimize, and force. You guys see that we use that in a lot of different places, and that's going to be very useful. And we have worked with other companies who work in this space, and like we seem to all converge on like this idea is the right kind of idea for performance improvement. And of course, like for the particular case, right? The measurement or the optimize or even the enforcement might look very different from what I have shown here. But the idea is that we should have all these three phases. Second thing, check out the Club SDK. So if you're interested, we are working with like a small list of companies that we want to like beta this SDK before we do a bigger release. So if you're interested, talk to me. I can get you on that list. The third thing is that it's all about the performance mindset, right? I mean, people have to start thinking about performance if they want to create like great performance. Like, and you have to bring that mindset throughout the whole team, from the designer to PM to all the other engineer, front end and back end. If like take an example, if the designer give you a design that is very fancy but impossible to implement in a fast and performance way, then there's no way you can build like a performance app with that, right? So it's really a performance mindset that you should take away, and you should like bring it to the team, talk to everyone, like have people thinking about performance, and get them to start thinking about it, put it on their head, and then they will. You're gonna see some improvement like going through this, right? That's about it. Thank you for listening.